This is the screencast for section 8.3, example 4, comparing logarithmic functions as x approaches infinity. So let a and b be numbers greater than 1. Show that the log base a of x and the log base b of x, so no matter what they are, as long as the base is greater than 1, grow at the same rate as x approaches infinity. Alright, so we're looking for the same rate, so not infinity or 0. So I'm going to start out with the limit as x approaches infinity of log base a of x over log base b of x. Now if I use the change of base formula here, I'm going to say that's the log of x over the log of a for the numerator, and the log of x over the log of b for the denominator. So I changed the base to 10, which is kind of nice because then the log of x's cancel out if I multiply by the reciprocal of the denominator, and I get log of b over log of a. Now, I know what you're thinking, this isn't 1. Well, yeah, but we don't need to find 1. Remember back at the definition, all we need to find that f and g grow at the same rate is that the limit of the quotient of the two functions equals a constant, finite and not 0. So it doesn't have to actually equal 1. So therefore, y equals log base a of x and y equals log base b of x grow at the same rate as x approaches infinity, just because that's a constant. It's not infinity, it's not 0, it's just 2.76514 or something. The now try problem number 13 says show that the two functions grow at the same rate. So I'm going to do the limit as x approaches infinity of the natural log of x all over log of square root x. Now, you might go to the change of base formula right away, like we did in example 4, but let's think a little bit differently about this one. I know that the log of square root x is really the log of x to the 1/2, so I can take that 1/2 and put it down as a coefficient, which means then, if I keep this simplifying pattern down, the 1/2 brings the 2 in the numerator. Now let's use the change of base formula and get that log base 10 into log base e. So that would be the natural log of x over the natural log of 10. So the natural log of what you're taking the log of divided by the natural log of the old base. The natural logs now cancel out the natural log of x, and I get 2 times the natural log of 10. So even though that's a funky number, it is still a constant, so I can make the conclusion then that y equals natural log of x and y equals log of square root of x grow at the same rate as x approaches infinity.